first step is to unplug the waterproof connector, remove the pulse module, and push out the main drive gear from the rear. Now the next thing you want to do is to inspect the drive gear teeth for wear or damage or being stripped. You want to check the main drive shaft for wear or damage, and you want to inspect the worm gear for wear or damage. You can check the two plain bearings and check the fit. There should be a nice fit like that. There should be no slop, and that should be a nice fit. And that's the first step. Step 2. Notice there's an alloy top hat bush here, and then just in front of it is a black circlip. Make a note of the gap between the bush and the circlip. You'll probably find it's in the region of about 0.5 millimeter. That's half a millimeter, which is what mine is. I can just get that feeler gauge in there. The important thing is to note what it is, and then make sure that you put yours back exactly the same. Unfortunately, I didn't record what mine was. I've just taken an educated guess. Then you'll need a flat blade screwdriver that's been modified to have a notch in it. And notice on the end of the housing there, supporting the armature worm gear, is a black hard wearing plastic adjuster. So it's a black adjuster with a split flat blade drive. So remove that adjuster. You may find that it's been thread locked. I think mine was. I'm not sure that it needs to be. The only thing is that as the worm gear turns around, it's tending to wind or unwind the adjuster, so that's maybe why they thread locked it. So remove that adjuster and be careful not to lose it. It's a vital component. Step 3. Note around the motor cover edge where I'm scribing, you may have black auto seal applied all the way around there and all the way around the back, which I think was AC Delco's attempt to seal the body. The main casing for the wiper motor has got two magnets inside, as you can see. They are very powerful, so be careful when you're leaving this on the bench in case you get screws or metal going inside there. It can be very difficult to get out, particularly if it's gone round the back end of those magnets. So just be careful, put it somewhere safe, don't let anything get in there. It could be disastrous. I actually lost a couple of screws down there and it took me ages to dig them out, so just be careful, and it will, if you put it on the table, it will suck things up inside. It's very strong. You need to remove that seal as best you can to get it free. Once you've removed the black auto seal, then there are two screws which are, I think they're Torx T20 bits. Remove the two screws and then remove the motor cover. You'll find there are two magnets inside the motor cover which make it want to pull itself back on. So that's step 3. Step 4. As mentioned in the previous step, there's a circlip that's on the shaft, on the armature shaft, and that goes around in a groove just in front of the top hat gear. Take some long nose pliers and push either side of the circlip. Push either side of the circlip. You may have to hold the armature in your hand while you do it. Push it down, and you'll find that if you can see that it's actually pushed itself against the diecast body so it couldn't come off. Now I can grab it and I should be able to just remove that circlip. That's a crescent shaped circlip. They're not easy to obtain, so try not to lose it. It may be possible to replace it, but it took me a long time to find them, so try and keep that safe. I keep a bag of bits for everything that comes off. Step 5. A quick note on the motor PCB inside. You can bend these little tags back to pull the springs out, and it's advisable to take the springs out because you can't easily move the motor around inside with those pressing on it, and you're likely to damage it. You can see the graphite carbon rods that touch on the contactor. In order to remove the armature, I first recommend that you take the springs out the commutator contacts. There are 3 springs, and to get at them, each one of these contactors has got a brass retaining clip which you can pull out. When you spring it out like that, you'll find you can take out the spring. You can remove the spring, keep the spring safe. The reason why we do this is because as you're removing the shaft, you'll find the carbon brushes will tend to rub on the contacts, which could damage them. So you need to just push out these little stops. Be careful because the springs may just jump out, and these have been out once already, so it's a little bit tricky. There we go, there's a spring that jumped out, and the last one. Just note that the actual carbon brushes, there are 2 of one type and 1 of another, so one is a kind of a vertical. Now I'm going to have to get a tool to prise that out. Did too good a job at fitting it back in. So there's the last spring. Then make sure that you pull back the carbon brushes, which, if you can see, it's very difficult to show you, but there's a wire on each one. I think you can see there's that wire, so you can just pull the brush back, which will stop it rubbing against the shaft. So my brushes are now not touching the shaft at all, not touching the contactor. Step 6. The armature shaft has a press fit bearing which is housed inside this diecast body here. It may be necessary for you to do this in a vise. If so, put the diecast body this way up in a vise, using the jaws of the vise to act as a stop. Don't grip this housing, otherwise you'll damage it. Then put a shaft somewhere between 6 or 7 millimeters in diameter. 7mm I believe will fit inside there, and then you're going to tap the shaft out. Now initially I had to use a lump hammer, but this shaft has been out before, so I'm going to try and tap it out in front of your very eyes. There we go. So now we've tapped out the armature, which is a big step to take that out. So now we can move on to the next step. As I mentioned, this is the pulse module. This is what the pulse module looks like when you remove the PCB. You can see there are these 12 connections down here and 3 connections from the motor power on this side. They connect into the circuit board through these holes in the board. Now these holes are plated through. What that means is that the circuitry on this side is electroplated through the holes to the other side, which means the bottom side connects to the top side through the hole. If you're not careful when you're desoldering these, you will find that you pull the little plug of copper that goes in the hole out, and then you will lose connection from top to bottom. And what that means is you cannot solder on the other side here to make a connection, so it basically writes the board off. So that's what happens. These are the little relays that are on the board that a PCB mount, and you can see that mine had some damage on the tracks. One of the resistors, which is one of these little surface mount resistors here, was completely eaten away, so I put a standard resistor in and a little wire, and this pulse module now works fine as a spare. So I have a spare one, and as you can see on this side is the microcontroller. There's a crystal here, a fair few diodes, some capacitors, and on the other side is this part here, which is the, sorry about the focus, but when we're doing this, so that's the little Hall effect sensor. I do have some circuit information for this, which I'll try and show you later. So that is a disassembled pulse module, and there is the complete thing, which I believe works. At the moment I have no way of testing this on the bench. Step 8. This next step, I recommend that you clean up the armature as best as possible. Wipe off any grease that you've got on there, off the worm gear. I will try and show you and add a piece into this clip where my shaft has been what I call brunelled. That's where it's overheated and it's been running around and wearing, and it's roughened itself up, and it did it on both ends. You may even still see a little bit of sign of it on the shaft. But as you've tapped this out, you will no doubt have burred the end of this armature shaft, which is probably a softer finish. So we need to remove the burr off of here, because the end of this shaft runs around in that little plastic adjuster, and that plastic adjuster will just wear away if this has got a lip on it. So we just need to take off the edge, just restore it back to as it was. It's not difficult to do, it's soft. A small fine file will do, and it should be nice and smooth to the touch. Right. That's smooth all the way around. So the armature has been cleaned, that end is now being deburred. There is nothing on there, nothing to catch that plastic adjuster. You can see these contacts on here. I already cleaned them previously, but I'll wipe any grease off and I'll stow this away ready for reassembly. Step 9. There will be an O-ring around the diecast body, which you need to remove. So we just take the O-ring off. You'll see that it just should come out like so. Keep that safe and clean, and don't cut it or damage it. Now this is going to be a little bit hard to explain from this particular part, because I've already modified this. You can see I've added 2 cap head screws there. They're M3 by, I think they're 8mm long socket cap head screws. Now on yours there will be 2 posts that protrude from the diecast body, and you're going to need to center dot those and then drill them 2.5mm and about 10mm deep, okay, because they're going to be tapped later. So let's just assume that that's where we are. I will support this with some CAD pictures later. Unfortunately for me, I thread locked these. I didn't expect to be doing this again, but anyway, there we go, they were thread locked. The trickiest part will be actually supporting this somehow while you drill it vertically. If you're drilling it by hand, you're going to have to be quite accurate. If you have a pillar drill, it would make life a lot easier. So there are those two screws removed. So now you can see this is what you will have. I never had this because I didn't realise how it assembled and was constructed, so I couldn't work out how it all came apart. So now this PCB will come out. At the moment I've sealed mine with rubber, with auto seal rubber around here, right, which made that a little bit hard to come out. Now notice in the center here is this plastic bearing assembly. This plastic, I don't know what it is, it's like a plastic seal. There are two parts to it. There's an inner and an outer. And I was trying to work out what it is, and I've actually sourced an oil seal that fits in there, but I haven't used it because I was worried that the oil seal may short to the PCB. You can see the PCB contacts here. There are where the commutator carbon brushes actually mount, go around the edge. Now if you put an oil seal in there, it will press on those. The oil seal is slightly thicker than it needed to be. Mine was, the ones I found was 7mm thick, and it just meant there's about a 1/2 mil sticking out, which wouldn't be a problem. We can soon put some washers on the screws when we put the PCB in, but I didn't want to risk these short into the case because that would short your wiring straight to the case. So these plastic spacers may indeed just be insulating bushes that go in there. I'm not sure exactly what they were for. So that's that part. Then also notice at the bottom here is this crescent shaped press-in washer, which I'm not going to remove at this stage, but the way you remove it is to get in from the side, tap underneath it, and then just keep going around and gradually prise it out. You're going to need to keep it intact so you can put it back in, unless you put in one of the oil seal bearings, but I've not tried that, and at the moment I don't need to. So you go around there and you remove that, and then your bearing, believe it or not, should just drop out. I will put some more video clips in about that a little bit later. Okay. Step 10. In this step we're going to remove the two plain bushes that are in this hole, which are for the main drive gear. Now there's two ways you can do it. To begin with, I used a bearing filler, which you can buy very cheaply. I bought a kit of these on eBay, all different, a range of sizes, amazing really, and they only cost £15 sterling, which is about $22 or somewhere thereabouts. It's not expensive in the grand scheme of things. What you do is you put your pull it through between the two bearings, you tighten it up on here, and it splays the collet out below, and then you just literally extract the bearings, and it was really easy, very, very easy. I didn't realise there may be an easier way at the time, so I'm going to show you the second way, which is cheaper. May not be quite so easy, may take a little bit more effort, but because these bushes have been out already, in this particular case they will come out. And that is to get a M8 cap head socket screw like this one, if you have one, or something with, you know, a 13mm diameter bar of some kind which has got a nice end to it. And then what you can do is you can just tap out the bearings. So they come out as simple as that. And believe it or not, you can use the same technique to put them back in. That's really simple. We will do that later. Step 11, clean up the die-cast body as much as you can. Remove all the old oil, make sure that it's squeaky clean, clean all of the surfaces. On mine, I don't know if you can see, but I've had some corrosion just round by my finger in there. I think you can just see it here, right? Which I've removed most of it, and I've probably gone as far. It's just discoloration now rather than corrosion. So I took all the rust, all the corrosion, got rid of all of the grease, and now I've got a nice clean body ready to start reassembly. Step 12. You may have noticed there's a little white access hole here. Trust me, it doesn't go anywhere, it doesn't do anything, it just literally pokes into this. There's a cavity there and it goes nowhere. It doesn't serve any function whatsoever. And I did take mine out just out of curiosity because I was trying to work out how to remove the bearings. This is just a little plastic cover that just pops out. You can get it from the side with your scalpel and just pop it out, get with your knife blade in there and just pop it out. The point being is that I believe that moisture can get around this little seal. It's not a very good fit. So after I cleaned my housing up, I took that out and I filled it full of auto seal and then I put it back in. So if we look on the other side, you may be able to see, I don't know, you may be able to see this in a dark hole down here, but there is actually a little glimmer of auto seal down there. Okay, so you can see it. And I think that just for the sake of it means that you're reducing the risk of getting any more damp or condensation in there and affecting the performance. Step 13. Now you will have your 2 holes drilled, ready for tapping, and you will have drilled them 2.5 millimeters and about 10 millimeters deep from this face here. But you may be left with some remnants of the original posts that are on there. So I advise getting a slightly larger drill or a countersink drill and just taking the top off and making it so that these are nice and flush and smooth, because they're going to be making contact with the PCB points here. You can see there's 2 of them, those 2 points. They're going to be making contact because this is actually grounded by the die-cast body. So that's the next step. Remove the burrs with a drill and then carry on and tap the holes nice and square, and these are going to be tapped M3. So that's an M3 tap. You can see I've already done this one and they will fit in there nicely. That's tapped M3, you see. So those have been tapped M3, ready to go. And that's all the machining you're going to need to do. Step 14. In this step, we're going to restart reassembly. Make sure you've fitted the little top hat bush that fits in here. It's an alloy bush that just sits in there. Place in your new bearing, which should just drop straight in. There shouldn't be a lot of effort required to get that in there. If necessary, you may have to tap it in. I don't know. I can't say for all the others. And then you need to return that crescent-shaped spring washer, which mine's already in there, and then you line that up, and I've got a socket here which is a 15mm deep impact drive socket, and then you can use that to just tap in your crescent-shaped washer and make sure that's seated firmly home. Once you've done that, you've actually repaired this housing by putting in a new bearing. You will notice that the armature is going to be a press fit into that bearing. It's not just going to drop straight in, so we're going to have to tap that in a bit later. Step 15. Now we're going to refit the PCB. This is the Commutator PCB. We're going to start by putting it in place and not forgetting these two plastic remnants of what I think was probably an oil bearing originally. So you put those back in place, then you get your auto sealer and just put some around that joint there. You can trim it up later, tidy it up later, but it's just literally, that's a weakness in the actual construction of this. It's always best to clean everything with IPA, which is, or rubbing alcohol, before you start to make sure that everything is degreased, otherwise the glues tend not to stick. So then you can put your PCB back in place, and then we're going to put our two M3 screws in with a little bit of thread lock on them. This is a low strength thread lock. I don't think it makes any difference whether it's high strength or low strength. Just start those in the holes. I'm going a little bit quicker here. You'll probably take a lot more care than me. I'm doing this so that you can see what's going on. Okay, they've been done. There are lock washers on these cap-head screws. There's a washer and a lock washer, and there's thread lock on there, so they should never come undone, I don't believe. So that's that. That's section completed. Step 16. In this next step, we're going to refit the armature back in place. Now, you can start by lining it up, and then the end of the shaft for the armature has actually got a chamfered flat on there, and this part of the shaft is very hard. So I think it's quite okay. If you've got a copper hammer, it would be better. I don't have one. So I'm just going to tap this shaft back into place. We'll start gently first of all. Right, so it's now started to go through. It's going to be hard to show you this and do it all at the same time, but I'll try my best. It probably moves about 1 millimeter per tap. So what we're going to do is get the groove that's in the armature shaft just proud of the little alloy top hat. Also make sure that when you're doing this that the little carbon brushes are sat back away from the armature, because you don't want to damage those as you're tapping it in. Now I can see that we've just cleared, difficult to show you, we've just cleared the little groove in the shaft. Is now just clear of that top hat. So that's in place, spinning around quite nicely. If you've bent over any components, make sure you put them back, but that looks fine. Step 17. First of all, we're going to refit the little crescent shaped circlip. I've got a pair of long nose pliers which you can get in and just fit it as simple as that. That's gone straight in. Now we can fit in the adjuster to the end of the shaft, so that goes in. We can tighten that up later. Then we have the 3 springs which we need to put back in for the armature carbon brushes. So we're going to put those back in, and we may need some little tools to help do that. So we now have the 3 carbon brushes now back in contact with the armature. Give it a spin around, make sure there's nothing snagging. So they're in. So that's the main part of that bit done. Step 18. Now we're going to refit the 2 plain bearings that we removed earlier. Well, I am. You're going to fit new ones maybe. So start off by taking your bearing, first bearing, and lining up with the hole. You'll probably find, like mine, it just tapped in with my thumb. Then get your M8 cap head bolt, and then just tap it home, and you'll hear it hit the end. There's an end stop. You'll hear the that's got to the end stop, and if you check on the other side, you've come through to the end stop. You can now get your other bearing and press that in, and look at that, I did that with my thumb, so that went in, no problem at all. Now what you need to check is that those 2 bearings are in alignment. Now it may be that when you first put them in, they may, I mean they're really nice. That's fine. They're fine. They are. Sorry, wobbling the camera there. So they're in there and they fit fine. So now we want to adjust our little end stop for the adjuster for the armature. Now you can see that's the way that fits in there, and it wobbles around. You see there. Now as we wind this in, you'll get to a point where it starts to tighten against the shaft, and the adjuster is almost home. I think perhaps in real life we'll put some thread lock on there to make sure that can't unwind. Right, so I've now reached the end of the end that stop. The shaft is not wobbling around. I can tell you if you over tighten it, it'll draw too much current. You can actually check the current on your multimeter to see where you are, but you can feel it. So if you tighten it up too far, or go too far, see that's really hard to turn. That's hard to turn. So I think if you take it to that point and then back it off a quarter of a turn, maybe even less, somewhere there. Just want it so it starts to just stop wobbling around in the hole, which is that's that point there. So that's the bearings in, and that's the armature in. So we're making good progress. Step 19. Now we're going to refit the motor cover. But before refitting it, make sure you've cleaned it as far as you can, especially around the inside where this O-ring is going to seal. Also make sure you've cleaned in and around the groove where the O-ring fits on the die-cast body. So now what we're going to do is we're going to apply some auto seal around that groove, just a little bit around the groove. It's a bit of a terrible glue to fit actually, so try to get some in around that groove. I don't think you really need to do this. I'm not a great fan of glues and seals, but since this is a rebuild, and you know I'm never going to take this apart hopefully ever again, I'm going to put that in there like that. Just put some seal around there. This is how this was actually originally done. You know, it was originally filled with seal, or on the outside at least anyway, which I think was just a quick fix to get over a recall that there was. So now we've got that done there, we've got that there, we can put the O-ring on there, like so, fit that in. Right, just keep hands clean a bit. I'm going to put some around on the lip on the motor cover. This stuff never seems to set, it just always seems to be sticky. Or it actually goes a bit like gasket really. You know, that feels so. There we go. So that's got seal all the way around there, done that. So now all we need to do is refit the cover. Notice on the cover there is a tab that lines up. It only fits in one position, and it actually goes in that way. And you may find it a little bit tricky because you've got the magnets fighting against you, and then you've got to get your shaft in the bearing, and then it's in there like that. Oh, and also just make sure you haven't left any burrs on that shaft before you put that back together, which I meant to say. So that goes on there. Then we can put the two screws back. In there. Like so. That's in there, tightened up. We can wipe off any surplus sealant. Now before, the sealant was just applied around the outside. I don't quite know how that was going to work because it didn't get inside. And you know, maybe you have got some protection, but I think putting the auto seal around the edge. So now we have our cover back on, and we've got the bearings fitted for the drive gear. They go in there, that can go in there, and the next stage is just to finish off. Step 20. So now it's time to refit our drive gear. So I'm going to put some grease in the housing. I've got some Castrol grease here. I know for sure that when you're using grease for plastics and metal, where they sort of interface together, there's usually a special grease, which I had some, but it seemed rubbish. I have to say, this looks more like the original grease that was in there. So we've got some grease in there. I'm going to apply some to the outside of the shaft, all the way around. I'll clean that up later. I've had this grease for years. Right. And the problem with the grease is it tends to go everywhere but where you want it. You know, it needs to go on the surfaces, and the surfaces are constantly being worked on, so the grease is sprayed, and there's not like a dash pot or something that keeps the grease going on them. So just want to make sure that all of the actual grooves of the wheel are filled with grease, just to give it a good start. So I'm just going to clean off the edges. We've greased up the housing, the worm gear and the drive gear, so they're all greased. That just fits in there. So that should be that. Now all we have to do is refit the pulse board Now I will do a section on making a gasket for this, but at the moment we'll just assume that you've got a gasket to fit. If you're going to fit a new gasket, make sure you remove all the old one, clean it and degrease it so that you've got a nice surface for the adhesive of the gasket to seal against. So that should now be our motor back together, plugged in, and we're going to give it a test. Step 21. To test the motor is quite easy. All you need is a 12-volt power source, and you take your ground wire. Ignore the fact that I've got a yellow wire on the end of it. It's just so that I've got a little pin to put in there. That goes on to the black wire, which is the common. Then you take your 12-volt line, which goes to the red wire, which is speed 1, which is the normal speed, not the high speed of the motors. And now the motor should start up. So there we are. The motor is actually running, taking about 1.4 amps at the moment, which is quite high, I would say. And I'm just going to adjust the back off the adjuster. You can see that it's current is reducing. That's about the point. So there we have our motor. We can test the high speed quite easily. Like so. You probably can't hear the actual sounds of this because I've got a noise cancelling system on the microphone, but there is a bit of a whir, but I think that's probably normal noise for a motor. So our motor is functioning fine, no graunchy bearings, everything seems perfectly okay. Step 22. Now it may be worth fitting some auto seal around the gasket area when you put this back together. So go around there, put some on there, put some on your gasket, because that's the problem with this particular design. The water gets in through that seal and then it causes the demise of the bearings as they get contaminated with water. So that's the problem. And it may be worth, like I've done here, just running the motor with the pulse module off for a while. One thing to say is do not grease the plain bearings. Just don't grease them because they're not designed to run with grease, and you'll find that over time it'll dry out and then cause the bearing to seal. It actually just has the opposite effect. I learned that lesson in the printer industry, where they had printers running in bearings and the engineers used to go out and just spray some oil on them just to get them working, and then 3 or 4 days later they'd just be dead. One thing to mention is don't forget the little thrush washer that's on there. That washer that's on there. Because the gap between the this pulse module and the top of that gear is set so that the pulse, this gear doesn't ride up and down. It just stays in one position. And that's how it's designed to be. So that goes in there like that. That's the job done. for watching this video. Please give it a thumbs up, share and subscribe. Oh, and don't forget the alert bell.